2023, the annual joint event of ENTSO-E and E.DSO, and I'm Laurent Descagnes, working in the innovation team of ENTSO-E. Today we are going to explore 12 projects in 3 key areas, which is electrification, digitalization, and cooperation. Before we start, I need to share with you 2 short public announcements. One of them is that, as you can already heard and saw, that the event is recorded. So we will be able to share it with you afterwards. And we are also happy to involve you in the discussions. For that, please use the Q&A function of the Zoom in this tab below. Feel free to post your questions anytime during the sessions, and the moderators will do our best to try to get answers for them from the speakers. Without further ado, I would give the word now to George Păunescu, who is a policy officer at DG Energy of the European Commission, to deliver the keynote speech. George, the floor is yours.
Thank you, Laurent. Good morning, everyone. And let me start by thanking E.DSO and ENTSO-E for the invitation. It is a pleasure to take part in the project session of InnoGrid, which announces to be very interesting, and the expectations are high after the very good sessions of last year. We have an overall exciting theme for the whole discussion. On the one hand, we look at advancing the energy transition, and on the other hand, of the element of urgency brought by the energy crisis. And then in the middle, let's say how we get the balance right between the two. And we have these 3 excellent topics for discussions announced by Laurent: electrification, digitalization, and cooperation. Let's start the day by taking a general view at what is happening on the policy scene and what are the linkages with the topics of today. So we are all witnessing the deep transformation of the energy system, and even more, we all contribute to it from different positions, moving towards full decarbonization. The energy transition is an utmost important component of what is also called the twin transitions of the European Union, green and digital. But I dare to say that there could be hardly any green or any digital without energy. So this is vital. And I want to underline what are the 3 main drivers that are behind the energy transition. First, we have the European Green Deal, that is the master plan for successfully transforming our society towards full decarbonization by 2050, while maintaining and increasing the welfare and having a modern, resource-efficient and competitive industry. And for the energy, we have 3 key principles for the clean transition. First is to ensure a secure and affordable EU energy supply. Then we need to develop a fully integrated, interconnected, digitalized EU energy market, and additionally to prioritize energy efficiency, improve the energy performance of our buildings, and develop an energy sector based largely on renewable sources. And I would say that this strategy sets the scene for the energy transition. And next, we have a structured framework for the implementation. And this framework sets the pace of the transition. And it is represented by the so-called Fit for 55 package that represents a legal package, including not only detailed rules for implementation, but also setting clear targets that we need to achieve. And after we have set the scene, on the one hand, we agreed to the pace of the transition. We unfortunately faced an additional challenge, which brought a higher level of urgency than the one we already had, brought by the climate crisis. We witnessed the unprovoked and unjustified Russian invasion of Ukraine, and we saw how high was the impact on the energy markets, and this prompted a rapid response from the Commission under the form of the REPowerEU plan. And this plan accelerates the pace that we have previously considered. And then we have some prime examples of accelerating the pace, which were given by the Commission proposals for revised Renewable Energy Directive and the Energy Efficiency Directive, speaking of the targets that we assumed. Here, the co-legislators, meaning the European Parliament and the Council, have reached provisional agreements on targets with increased ambition compared to the initial proposals. And these are 42.5% share of renewables by 2030 and 11.7% additional savings by 2030 compared to 2020. Additionally, the Commission recently published the Green Deal Industrial Plan and the Net Zero Industry Act, which both address the technology and competitiveness aspects that we see that they are very important. The aim is to boost the European production capacities for supporting the energy transition and to strengthen investments in this area to improve our resilience in the process of reaching the decarbonization goals. And this is another good example of moving forward as fast as we can. Now, after looking at the transition, at the urgency elements, let's move on how to get the balance right. And I would say, well, it's never quite easy to get the balance right, is it? But I'm sure that the interesting discussions of this year's conference will result in some very good ideas and takeaways on how to do that. So we start the InnoGrid conference this year with the project session as usual. And this is very good because the research and innovation brings strong responses to the problems in question. It supports the energy transition and it does so in a good coordinated way. And on the research and innovation side, we have some good news. And looking again at the three discussion topics of InnoGrid, I will start with cooperation. We, of course, need cooperation among the main players on the integrated energy system. And we'll hear from projects today that will demonstrate this. But let me demonstrate this as an implementing level. But let me refer to other levels of cooperation also to bring them to the discussion, because we have a thorough and very participative process of identifying and developing the topics that drive the research and innovation. And then we transpose them in work programs and calls for projects. And we have the main funding instrument, the Horizon Europe, which is one of the largest research and innovation programs in the world, with a budget of more than 95 billion euros for the whole period 2021-2027, the current programming period. And I'm actually very glad to see in the program today many Horizon 2020 and Horizon Europe projects that will share their experiences. And then Horizon Europe is successfully complemented by national research and national programs and the way they cooperate across member states within the Clean Energy Transition Partnership. And we'll hear today from these kind of projects as well. We cooperate successfully not only in setting the priorities, but also during the implementation of the projects. And we have a vibrant Commission initiative called Bridge, which is a community of projects working on smart grids, energy storage, and digitalization, and they share experiences and benchmark solutions, approaches that feed their lessons learned back to the Commission, to the policy making. And here again, I'm glad to see that out of these Horizon Europe projects, there are important contributors to Bridge, participants of today. So we are in a very good position of coming up with research and innovation actions. We are preparing the ground right, and we are covering, we do this in partnership, and then the projects will cover the electrification and digitalization, which are are essential for a successful energy transition. And the last, I wanted just to mention the good news of the availability of funding, because I have mentioned the Horizon Europe, and for the whole 2021-2027 program, more than 7 billion euros are earmarked for energy topics, and these are complemented by additional 8 billion earmarked for climate and mobility, which are closely supporting energy and include many related topics, such as e-mobility. And then, of course, we have the national funding, as I mentioned, and the Clean Energy Transition Partnership. So the good news is that the financial allocations is indeed matching the policy priorities and the level of urgency. But I'll stop here with this general introduction and framework. And let's hear from real-life projects and see how all this is put into practice. And let's discuss how we can strengthen the energy transition, address electrification, digitalization, and cooperation, and how we can do this at the the fast pace that is needed. Thank you.
Thank you very much, George, for this keynote speech. We will meet a little bit later at the end of the conference. And again, thank you very much for staying with us for the whole session today. Moving on to the first panel. No, sorry. Before moving on to the first panel, I should have given you a third public announcement. Is that after the event, we will share the presentations with you. So just to avoid some questions about it, we will of course make it available to all of you. So now moving to the first session about electrification, we have 4 projects on a very colorful scale, because all 4 projects are approaching electrification from a very different angle. So here we have with us Elisa Birona, who is going to present us Terna's electricity system innovation program. Sorry, electricity system innovation program, and who is head of energy system innovation at the Italian E.DSO. We have here Samuel Borro Vicente, Director of Electrical System Areas of the Spanish Research Center CIRTA, on behalf of FlexiGrid. We have here Nikos Bilitis, R&D Project Manager from European Dynamics, Greece and Luxembourg-based software developer and provider company on behalf of iStentor project. And we have here also on behalf of Gente project, Benjamin Bowler, who is a Senior Research Associate at Lucerne University of Applied Science and Arts. So let's start with you, Elisa, and please take it away.
Okay, good morning, everyone. First of all, I would like to thank you and the organizer for giving me the opportunity to present this Terna project called ESI program, so Energy System Innovation Program. The ESI program is a framework created to allow Terna's collaboration with external stakeholders, such as research institution, university, company, so third parties, but also BSPs and technology provider, in a transparent and participatory way in favor of the energy transition. This way, Terna wants to stimulate the participation in the market of all those resources that are currently not present in the electricity market due to, for example, low technological maturity. So far, the pilot project carried out under ARERA, the Italian regulatory authority, so under ARERA resolution number 300 of year 2017, have allowed the integration into the market of some small resources. However, not all the available resources have participated in this pilot project. Terna has therefore decided to launch, together with the different stakeholders of the energy system, innovation activities called ESI projects. Each ESI project will focus on specific technologies. The first wave of projects will focus on distributed energy resources, such as electric vehicle or heating, ventilation and air conditioning system that will be studied into different ways. As a single resource, with the scope of identifying their potential and limit, evaluating the specific technological future and the current control and communication method. And in this area, the idea is to propose a possible upgrade to facilitate the grid integration. The second way we will study the resource is as an aggregated resource in order to assess the performance and the reliability of the aggregates. And we want to focus on possible critical issue due to the multiplicity of the resource in control, communication, and monitoring phase. But why did we choose distributed resource as the first wave? Next slide, please. Because as you can see from the data in the table, in the slide, this data show the electrification scenario in terms of number of pod, the point of delivery, and megawatt installed by 2030. And you can see that the 95% of the new resource are basically distributed resource. In particular, they are charging infrastructure for electric vehicle and air conditioning and cooking system. The data refer to the scenario elaborated in the Integrated National Energy and Climate Plan, and could be greater considering the Fit for 55 target. These additional gigawatts are a challenge to this distribution grid if not properly managed. Next slide, please. So in the program, in the IC program, the chosen path is articulated in the following IC project: e-mobility, with a focus on single coupled and electric vehicle charging infrastructure, launched already in December 2022. The experimentation are being launched at Terna e-mobility lab in Turin. You can see a picture in the slide. With vehicle and charging infrastructure manufacturers. This experimentation will allow us to understand the ability to provide ancillary service to the grid and the impact on this service on the car batteries. The second project is easy heating and cooling with focus on the heat pump, boiler, and so on, studied as single resource, which will be launched during 2023. The test will be carried out in a laboratory chosen and made available by Terna to understand the capacity of this market, this machine, to provide ancillary service to the grid. They must be controlled in power and not in temperature. Both these two ESI projects have the ambition to contribute to the definition, the standard, both at Italian and hopefully at European level. Last but not least, during 2024, the third ESI project will be launched. It will study the performance of homogeneous and heterogeneous aggregates of electric vehicle in pumping system. The test will be conducted jointly with the stakeholders such as the aggregator. Thank you all for your attention, and I'm available for any question.
Thank you very much, Elisa, for your presentation. From the TSO focus, let's move now to more DSO focused project, FlexiGrid. Samuel? Yes, the floor is yours.
Okay, thank you very much. Good morning, everyone. Well, first of all, thanks to E.DSO and ENTSO-E and InnoGrid for the invitation to be here on behalf of FlexiGrid project and System Technology Center. Well, let's have first overview of FlexiGrid project, which is Horizon 2020 project. So next slide, please. So the main objective of FlexiGrid project is to provide technology tools for the distribution networks to be operated with security, stability, and reliability in scenarios with a high penetration of renewable energy sources connected in medium voltage and low voltage distribution systems. So we are talking about distributed generation, no? Connected in these low voltage and medium voltage networks. So the expected impacts that we want to achieve with the implementation and deployment of the different solutions developed in the project is an improvement in the stability and flexibility of distribution networks, or in general in power system, decrease in the curtailment of renewable energies, reduction of the rangeformants needed to maintain the quality and stability of the grid, thanks to a better planning and especially monitoring and operation of these networks. Also to improve the capability to manage future energy loads, and this is related with this scenario of electrification. So we are talking about the increase in the electric demand, and also specifically about different type or new type of loads, such as some of them they are coming, such as the electric vehicle, for example, or the increase of storage systems. And finally, an overarching impact, which is the reduction in CO2 emissions, mainly thanks to the larger penetration of renewable energy sources, and also thanks to this increase of electrification provided by the enhancement in the operation of the distribution networks. So some data, general data and figures of the project. We are 17 partners, and I think that covering in a good way the value chain of the energy sector. We have technology centers such as CIRCE from Zaragoza, Spain, which is the coordinator of the project. We also have links from Italy. We have DSOs on board. We have E.DSO EDP from Spain, EDINA from Italy, and HEP-ODS from Croatia. We have technology providers and big companies such as ZAB, Ormazabal, and Atos from Spain. We also have companies, technology companies such as Celta Digital Platforms from Italy and Hypertech from Greece. We have an aggregator, which is BERD, as part of Motor Oil Elas in Greece. We have the owner and operator of a specific demo site, which is IOSA from Greece. We have on board universities such as the University of Cantabria from Spain and the University of Zagreb from Croatia. And we have the association Cap Energies from France. So we have 5 countries among the different partners. FlexiGrid project is an Horizon 2020 innovation action with a budget of 8.5 million euro. We started at the end of 2019, so at the beginning of the project, we suffered somehow the pandemic, but we were in the development phases of the technology solution, so we could cope with this situation, and finally now, which we are facing the final phase of the project, we are in the deployment and demonstration phase of the different solutions. So next slide, please. So regarding the contribution of electrification of FlexiGrid 2 for electrification, considering this electrification part of the different challenges of the power system for the energy transition, along with the integration of renewable energies and the reduction in emissions. So the distribution networks and power systems are play a relevant role in this electrification and this transition. So with this perspective, FlexiGrid project contributes developing hardware and software technology solutions. We will see later a little bit more detail of the solutions with these aims, with these main objectives: to improve the power system flexibility, to increase the hosting capacity of renewable energy sources, to increase the observability, controllability, and automation of the electric networks, and with this improving the security and resilience of the grids, to mitigate short-term and long-term congestions in distribution networks, and also to ensure the interoperability and compatibility of the different solutions among them and with the different platforms used by DSOs. These solutions are being validated, deployed, and tested in 4 demo sites, each of which implements 2 use cases. So I briefly will mention the different demo sites. Demo 1 takes place in Spain, in the north of Spain, in rural and peri-urban areas. It is coordinated by E.DSO EDP, the DSO of this area. Here we implement 2 use cases. The secondary substation upgrading for higher and grid automation and control, and also the implementation of protection functions ready to operate for scenarios with high penetration of renewable energies. Demo 2 takes place in the Thasos Island in Greece, coordinated by BIRD. Here we have a green resort with distributed generation, storage systems, and manageable demand. So here we implement, on the one hand, the holistic energy system optimization for commercial and residential customers, and also microgrid congestion management and peak saving. Demo 3 takes place in Croatia, in the urban area of Zagreb, and it is coordinated by HEP ODS, the DSO of this area. Here we are implementing the coordination of distribution network flexibility, assets, and protection schemes, specifically for the medium voltage and low voltage networks for urban districts, and also virtual energy storage for urban building, which is a model related with the flexibility in the demand side. And Demo 4 takes place in Italy, in the Salentino Valley, in the center of South Tyrol, and it is coordinated by EDINA, which is the DSO of the area. Here we are implementing a dispatched platform for the hydro generation connected to the medium voltage network of the valley, and also the systems and monitoring and operation system for the operation of the valley grid in island mode due to the weak connection of this distribution network with to the high voltage network in the area. So next slide, please. So finally, talking about the main key exploitable results. Well, here you have the 9 solutions, the hardware and software solutions developed in the project. So the role for exploitation, we have 4 hardware solutions. I will briefly explain now, and 4 software solutions. So the hardware solutions are more related with the technology developers and manufacturers and integrators, and the software solutions are more related or more exploitable by operators of these networks, such as DSO, aggregators, or so on. So just to mention the solutions, we have the secondary substation, what we call secondary substation of the future, which consists of a distribution substation with enhanced automation and advanced monitoring and operation capabilities, and it also includes what we call in the project the Smart Trafo, which is a compact, intelligent distribution transformer with automatic load regulation. We have the smart meters, new generation of smart meters with the main new characteristic is the feeder mapping capabilities, which allow the network operator to map with more accuracy the topology of the low voltage network. We have protections ready to operate for scenarios with high renewable energies penetration, in which the behavior of the system is different than the one with conventional generation. We have the energy box, which is a multi-purpose gateway for smart grids that with versatile communication capabilities, and also computing capabilities. Thinking of edge computing and IoT. Then we have the software modules, which are a set of algorithms to improve the operation of the networks. So we have software module for fault location and self-healing, Here we are developing algorithms for detection and location of faults in medium voltage network and provide recommendations for the automatic restoration of the energy supply. We have software module for forecasting and grid operation, which is a set of algorithms to predict generation and demand, and accordingly to provide, again, recommendations to operate on network flexibility assets, such as distributed generation, storage systems, or different network operation that can be helped in this sense. We have software module for congestion management, specifically for congestion management, which includes mechanisms to recognize congestion situations and manage them, considering the market perspective. And we have another software module, which is this virtual thermal storage model, with models the thermal capacity of home water heaters to quantify and provide flexibility from the demand side. And finally, we have the Fuse platform, which is an open platform which aims to allow the integration of the different developed solutions, especially software solutions, and the communication with the field devices, and also with the platforms of the network operator. Okay, and these are the individual exploitable results. But next, please. If we consider a holistic implementation and deployment of the solutions, I think that we can even improve the impact of the solutions. There are some examples, so we can integrate the hardware architecture, such as the secondary substation with smart meters, and also with new protection and for location systems, and regarding the energy box, which can be used both in secondary substation level, but also if we think in end users, it can be also a powerful tool to implement different algorithms and operation strategies for microgrids and more use-oriented networks, such as aggregators or self-consumption and so on. Okay, so that's all about the solutions, and thank you very much for your attention, and ready for any question. Thank you very much.
Thank you very much indeed, Samuel. And as you also said, I would also encourage our attendees to post any questions anytime you would like to in the Q&A function of the Zoom. So now we are moving on to the third presentation, Nikos Bilitis and the iStentor project. Now we were dealing with the grid, and with iStentor we moved to storage. So Nikos, over to you.
Thank you, Laurent. Okay, so good morning to everyone. And again, from my side, I would also like to thank InnoGrid for allowing us to present our project. So my name is Nikos Bilitis. I'm an R&D project manager in European Dynamics, and I'm the coordinator of the iStentor project. iStentor stands for innovative energy storage technologies towards increased renewables, integration, and efficient operation. If we can go to the next slide, please. The project started in January of 2023, and it is going to run until the end of 2025, covering a period of 3 years in total. The project is being funded by the Horizon Europe framework, and in total we received a funding of approximately 8.1 million euros from the European Commission in order to implement our activities. If we can move on to the main objectives, these revolve around 4 main pillars. Firstly, we aim to examine how different storage solutions can be applied to serve different applications, and how innovative storage systems can be combined into forming hybrid storage solutions. We will also examine the applicability of these standalone and hybrid storage systems in various applications that span from mobility to agriculture, to industry, to households, heating, and other sectors. We will promote the introduction of novel business models that aim towards the deployment of single and hybrid storage systems, And we will highlight their multifaceted role, not only as energy buffers, but also as active market participants and service providers. And finally, we aim to strengthen the storage European value chains and to facilitate investment planning on energy storage facilities. If we can move on to the next slide. So the project consists of a very wide consortium that comprises 27 partners that cover all different kinds of relevant expertise. So we have on board big ICT companies, technology providers, energy service providers, distribution system operators, manufacturers of batteries and suppliers of batteries, other big manufacturers, big research centers and universities, utilities, SMEs, and regulators. The project aims to contribute to electrification. If we can go to the next slide, please. So we are contributing to electrification through the solutions that we are proposing that are being showcased in 5 large-scale demonstrations that are deployed in 5 different European countries, and through a living lab, which will be acting as a sandbox to test our solutions. The demos will be deployed in Slovenia, in Portugal, in Italy, Spain, and Luxembourg. So we feature a big geographical coverage across Europe in countries with very different climatic conditions and different levels of regulatory and technological maturity. So this allows us to showcase the applicability of the iStandard solutions in very diverse conditions, and to highlight the interoperability potential that we are introducing. So iStandard introduces innovative control and management solutions of single and hybrid energy storage systems that aim towards a more robust operation of the power system, the reduction of curtailments from renewable energy sources, and the increased integration of renewables. It leverages existing and new interoperability traits to facilitate trusted sovereignty, data value creation, and governance in an attempt to create fully compatible solutions with different kinds of legacy systems. It promotes the participation of storage assets and the participation of smaller players in the energy and services markets. It enables the growth of the storage market and the formation of stronger value chains. And finally, it will aim to highlight the storage assets as a central component in the power system, in the future power system, by influencing future regulation and policies. So the most important key exploitable results that we have already identified are the virtual power plant that is integrating an asset register and allows the easy and interoperable management of versatile integrated storage systems, the degradation models for algorithms that allow the provision of ancillary and balancing services to the markets, an investment planning tool that assesses investments on storage systems that and it's based on different storage types and the specificities of the end applications, and incorporates the novel business models that we are designing in the project. And finally, based on the size and the multidisciplinarity of our consortium, we are confident that a very efficient exploitation pathway is going to be created in order to commercialize the solutions that we are proposing. So thank you for your attention, and I'm available for any questions.
Thank you very much, Nikos. And if you were wondering how we can talk about electrification without involving or mentioning the end users or the consumers, now we are going to fill this gap. Ben and Hente project, floor is yours.
Thank you very much. So I'll just wait for the slides to come up. So good afternoon, everyone. If you can go to the next slide, that would be great. Sorry, good morning, everyone. My name is Ben Bowler. I'm a Senior Research Associate at Lucerne University of Applied Sciences and Arts in Switzerland, and I coordinate the Gente project, which is a 2-year AeroNet project that started in June last year. And the project is focused on energy communities. And so taking some of the aspects that have been described in the previous presentations and really embedding them, testing them in energy communities in a number of sites across Europe. We're focusing on creating a toolbox for energy communities, and that toolbox has a number of components. Some of the components focus on energy optimization. So we have an IoT platform, edge processing, use of AI for forecasting. Some of it's to do with commercial value capture, revenue streams, and so on. So we've got DLT and smart contracting. And some of it involves actually methodologies and processes associated with setting energy communities up. So we've got sociological research looking at how you engage people in the design and implementation of communities right at the start where they're setting up. One of the interesting aspects of the Gente project is its focus on federation. So as well as optimizing energy resources within the community, we're also looking at how you optimize energy resources across the community or across different communities. So we're looking at how a community manager who might have responsibility for a number of communities might coordinate those for various objectives, and some of those might be grid services, for example. So if you go on to the next slide, please. In terms of demo sites, there are three countries with demo sites involved in the project. We've got 2 in Switzerland, 2 in Turkey, and 2 in Sweden. It brings us to 6 in total, and that will allow us to demonstrate the various aspects of the Gente project in various ways. Not all of those sites are at the same level of maturity. So one in Switzerland, for example, has fully deployed at the moment energy community optimization platform, and we're looking at how we could improve that with advanced analytics and artificial intelligence. Also in Switzerland, we've got a community that's just starting. So we'll be running co-design workshops with that community to develop the concepts with them. In terms of how we're contributing to electrification, there are 3 aspects, I suppose, that you could focus on looking at the Gente use cases, which are at the bottom of this slide. Firstly, we're looking at how you can more efficiently use the electricity network through things like self-consumption, peak load management, and providing flexibility to the electricity network. Secondly, regarding decarbonisation, we've got a number of KPIs and objectives that are focused on things like CO2 emissions reductions, reducing costs, energy efficiency, and reduction in consumption. And thirdly, in relation to achieving scale, so it's not enough just to do this in a couple of communities, we're also looking at how you could mobilize multiple communities in multiple different areas or across multiple different demographics. And so we're looking at community federation, as I've mentioned already. On the third slide, next slide, sorry. We've got a whole range of exploitable results. The project is not complete yet. We've still got some time to run. So in the process of mapping those exploitable results, I just focus on one aspect of the exploitable results, which is on the technologies. So on the left-hand side, you can see we go into a little bit more detail on the technologies, things like data analytics, management software, IoT platforms, DLT that I've already mentioned, data collection tools, applying those to IoT platforms, and we'll also be implementing a mobile platform within the community. In terms of how we're applying those and what our lessons are so far, we really feel it's important that those services are modular. So we're working on API interfaces to connect the different services, different technologies together across platforms and across providers. And it's also really important for those technologies to be transferable. So we're looking at how you can implement algorithms and forecasting and so on across different edge devices just to improve privacy, across servers based in communities, but also in the cloud. What we want to be able to do is to create something that's simple and that can give local energy communities superpowers. So simple applications that can be embedded in existing technology that allow LECs to do more than they currently do with the basic optimization tools. In terms of our ambition, we want those tools to be open source, and our ambition is to allow the academic research in particular to be exploitable by commercial partners, both within the project and outside of the project. As I mentioned, the exploitation pathways for the different technologies are in development, and we'll be publishing a deliverable about that soon. If I could just spend another 30 seconds or so giving some thoughts about exploitable results and our lessons about those so far. I think if you look back at energy communities and their historical deployment over the last 10 years or so in Europe, a lot of the deployment of energy communities has been focused on leveraging access to feed-in tariffs to revenue. And I think we're entering a new phase with energy communities where things like self-consumption, optimization, energy cost reduction are becoming much more important. This is a much more complicated scenario. The technology involved to do that is more complicated than just simply building solar panels and selling kilowatt hours to the grid. So we need technology that is simple, that's understandable, that's cheap and robust, and that's plug and play within energy communities. So these are all ambitions for our technology within the Gente project. We also expect energy communities to become much more democratic, much more focused around communities. However, that's not the case at the moment. So it gives us an opportunity to work with community managers to get the technology right, and so that it can be exploited by the more cooperative focused energy communities in future. I'll pause there and then we can move on to questions and I can answer any questions later on.
Thank you very much, Ben. And now I would invite all the 4 speakers to open your cameras so we can start the panel discussion part of this session. Thank you. So we received already a couple of questions from our audience, and I would again encourage you all to post your questions in the Q&A tab of Zoom. So starting with the first one, which is for Elisa and for the ESI program. The question is if the project results to be implemented by the industry for charging points, heat pumps, do you have any commitments from the major players, or maybe, yeah, this is something that you are still handling in the framework of this program?
Okay, thank you for the question. The results will be used for promoting the standardization, for example, both at Italian and the European level. So since we know that on this kind of research, there is not a complete standardization, for example, for the communication protocol. So we would like to see the results used for this scope. The experimentation are not started yet. They will start in the next week, but we have received some proposal for by some charging infrastructure manufacturer and electric vehicle manufacturer. So the experimentation will be conducted with them using the asset that this player make us available.
Elisa, do you see it as a challenge maybe in this program, or do you think that this part is something that you will be easily handle when the time is right for that?
But I think that is important to receive several proposals in order to can test much possible asset and provide to the system some results that are complete. So this is the big challenge.
I see, thank you. We have a question for you, Samuel, as well, and the FlexiGrid project. You showed us a quite extensive toolbox or set of solutions that you are working on in your project. Do you think that these solutions are covering all those issues that you are working on, or this was rather a summary or a result of a prioritization process? How did you end up with these specific solutions?
Well, in fact, we are now in this final phase of the project. We are analyzing these conclusions in order to understand what can be replicable, what should be further developed, and which other areas should be covered. But well, as you have mentioned, it's a quite wide extensive set of algorithms. We are quite focused on automation, operation, and flexibility solutions. But yes, we can think in elements that could be possible to further develop and further analyze. So, well, for example, I think that all the algorithms and the solutions related with flexibility in the network, with the operation of different assets within the distribution networks, I think that it would be interesting, for example, to keep on developing and testing these solutions or something or some evolving of these solutions, also with some kind of, for example, regulatory sandbox demo pilot integrating different market or local flexibility market environment to really test how these solutions could be deployed in a more, let's say, more real life conditions, no? Or for example, other solutions more technology oriented, which is one of the most promising solutions that we are developing is the fault location algorithm and prototype for distribution networks, which is, well, a quite novel technology based on reflectometry and some artificial intelligence algorithms. We have obtained very good results in simulation, and we are also, well, obtaining the first results in field, but probably it will be good to have more a wider test area, no? More different type of networks, more different types of tests to be performed with this new solution, and expand probably the impact of this solution. No? So well, in general, as I have mentioned, we cover a quite wide area of topics, but of course, we are thinking in the next steps to expand the impacts.
Do you mean by this, Samuel, that you would maybe in further steps thinking of how you would integrate these solutions with DSO systems as well, or you would stay at the DSO level?
Yeah, in fact, we have other projects with the DSOs, and well, I think that yes, that we have a good opportunity with these solutions developed, because in all of them we are thinking in creating platforms to integrate the solutions and to aggregate these algorithms. So at the end, in this project, we are more focused on secondary substation level, but at the end, secondary substations can be communicated, and probably the information and the inputs can be aggregated at primary substation, and then have some communication strategies with DSOs, especially in things related with flexibility, curtailments, and what problems in the operation of the networks, because the challenge and the objectives that we have mentioned related to congestions, integration of renewable energies, flexibility are common for transmission and distribution networks. So certainly, I think that we can try this cooperation. Okay, thank you.
Now let's switch to the other end of the grids, because there is a question for you, Ben. The question, it goes like, what about promoting cheaper solutions, such as not just to influence behaviors instead of putting a lot of hardware and software? Maybe I would add to this that, do you think that such kind of promotions can actually replace the need of hardwares and softwares?
Yeah, So yeah, thanks for the question. It's a good question and one that is often debated, I think. Just to clarify, DLT on my slide stands for distributed ledger technology, so I'm referring to blockchain. There was another question related to that, just a clarification point. But regarding cheaper solutions such as nudges, a lot of the research shows that that more sort of human interaction can be effective for the first short period of time, and then people start to disengage. So they might be engaged in a mobile platform initially, but then they start to become focused on other things, and they become less engaged in their energy platform and less responsive to that sort of demand response request that might come through nudges or something similar. So in that case, automation becomes important. I also think there's a second point, which is regarding the complexity of the grid, and we will very, very quickly, if not already, reach a point where it's impossible for humans really to be a meaningful part of the workflow here. I think as electric vehicles come online, as more and more energy resources are connected and have to be harnessed to support the local distribution network and support congestion in the local distribution network, the only option is automation. The only option is a technological solution which really takes the human decision making out of the direct process. We do have a responsibility, though, to make that technology safe, secure, reliable, cheap, and effective. So our challenge as researchers and as in delivering our projects is to make sure that we're not over-engineering things, that we're creating solutions that people can implement, that they can trust. And that covers also the topic regarding cybersecurity. So one of the things that we're looking at in the project is how you do a lot of the processing that you need to do, for example, forecasting of load curve data without actually centralizing that data. We want to be able to run load curve forecasts on edge devices so that the data actually never leaves the place where it's generated.
Thank you very much, Ben. Now to you, Nikos, because we have only 3 minutes, but I have a very specific question to you, and then a more general to all of you for one last quick answer. So, Nikos, you presented many interesting ways or approaches in your project. One of them was that you will look into the storage units degradation, and you will use some kind of modeling and assess how this can affect actually the services they can provide. So if I understood correctly, you don't handle the battery or storage unit degradation as a technical problem, but more like a business model problem, right?
So basically, I would say it's both, because we need to have all the technical details and the models of how each storage system, its different storage technology behaves exactly under different conditions, with the aging and everything that comes with frequent use, and also how we can optimally exploit the available capacity of a storage system at any given point in time in order to provide different types of services, either have the storage acting as a simple buffer of energy for serving certain loads, or allowing the storage to act as a service provider for the grid, but always having in mind how we will manage to ensure the maximum benefit for the storage operator, whether this is financial or any other type that we are examining at its given point in time. So we need the technology, we need the technical modeling in order to be able to simulate the exact behavior of the battery, and then we apply the business model that we are developing on how to optimally exploit this technology in order to participate in as many different markets as possible, although we understand that storage currently in most of the countries cannot actually participate in markets, cannot provide services, but this is something that we want to highlight, the importance of allowing storage assets to operate to provide ancillary and balancing services, and to influence as much as possible future regulation and policies towards this direction.
Thank you very much. And as I mentioned, one last question to all of you, very quick answers, please. Nico, starting with you, what role does cybersecurity play in your project? Do you consider it anyhow in your scopes?
Yes, indeed, we do. Actually, in this in the current setting, with all this data that exists and that are being exchanged between different platforms and systems, and given the fact that all these systems are critical infrastructure, cybersecurity is one of the most important aspects that we all need to take into account when designing such new systems and platforms. So in our case, indeed, we are trying to have to avoid centralized gathering of data, to have everything processed in the place where they are needed. And of course, always there is a need to exchange data between actors and systems. And in that case, we are trying to apply the most up-to-date, state-of-the-art technologies in cybersecurity in order to ensure that everything will be safe and secure.
Thank you, Nikos. Elisa, how do you deal with it in ESI?
Yes, also in ESI, the cybersecurity is a very important topic. So we would study also the protocol, and in order to understand if there will be some critically on charging infrastructure or the controlling of the pump. So it is a very important topic.
Thank you. Samuel, a very short answer, please.
Well, yes, of course, it's cybersecurity since the beginning of the project. It has been one of the critical points to be considered, because at the end we have different software solutions which share data, and also we are talking to integrate the solutions in platforms. No? So since the beginning of the project, we have a specific work package dedicated to the communication and systems of the project, led by Atos, and a specific task dedicated for the cybersecurity. You know? So I don't have the specific details of how I am not expert in this area, but it has been treated as one of the critical points, and well, especially for those data related to consumers, and also for those data on those interactions with the DSOs or real operation of the distribution networks.
Thank you, Samuel. And Benjamin, I trust your compactness in this last answer.
Yes, certainly. And I think I already answered the question to a large extent. So we're working with private consumer data. Cybersecurity is critical. It's a central part of the project. And we're applying edge approaches in order to be able to, in particular, edge approaches to be able to manage cybersecurity in an efficient way.
Thank you very much. And thank you very much to all of you, Benjamin Bauer, Elisa Viruna, Nikos Bilidis, and Samuel Boro Vicente. This was the first panel of this session today. And now we are going to the second one, which will be moderated by Selena. So Selena, please take it away.
Thank you very much, Laurent, and good morning, everyone. And we move to the second session of today, which is on the topic of digitalization. We have the pleasure to have 4 more projects with us that have developed and tested innovative digital solutions to accelerate the energy transition. So I introduce to you now our 4 speakers, starting with David Rua, Assistant Coordinator at the Center for Power Energy Systems at InnoGrid for the Interconnect project, William van der Broek, Innovation Consultant at ELIA, who's going to present their Moonshot Asset Management project, Ferdinando Bosco, Solution Architect and Researcher at Engineering, representing the Platone project, and last but not least, Daniele Porcu, Coordinator of the Smart 5 Grid project and Program Manager at EnerGrid. Before we jump into the discussion for this session, I leave the floor to the speakers for a short pitch presentation of their projects, starting with David and the Interconnect projects. David, the floor is yours.
Okay, thank you very much. I don't know if we can have the slide deck right after. Okay, perfect. Okay, good morning. First of all, thank you very much for the invitation. Unfortunately, I couldn't join the whole session since the beginning, but I've seen already the past few minutes good discussion on our colleagues in the previous session. So this session is about digitalization, and the purpose here is just to let you know a bit, if you don't know it already, of the Interconnect project, which is an H2020 project sponsored from DG Connect and DG NR. Where we're focusing on how to use interoperability to foster the support of data exchange between the different elements, ecosystems, and integration strategies from the demand side up until the grid. Our perspective on the grid, before we move along, yes, thank you very much, is in fact to integrate the distribution side mainly, but we're not stuck to that only. So we are a large project. We do have a pool of large experts on R&D from the demand side management. This is where we departed. We're trying to use demand side flexibility to operate different loads and different systems from residential and non-residential buildings to attain a specific set of objectives, which can pass through optimization of loads towards a specific load profile, price curves and whatnot, and even other incentives that can be convoluted or compounded to produce optimal results that rely on energy management platforms that allow these different systems to interact and produce in a most likely fashion automated actions towards technology and devices for the end user. So basically, we're uniting end users from domestic residential buildings and also end users that take part on tertiary buildings. The example could be, for instance, the supermarkets that we have demonstrated in Portugal, and also hotel chains in Germany, for instance, which are tertiary buildings in which users, which compound different sets of them, are also benefiting from this interoperability front. So what is exactly that we're doing here with the project? So we're pioneering on the side of semantic interoperability, and we're departing from SAREC, which is the ground which establishes the interaction between the different systems on top of existing standards that already ensure the connectivity between the different systems. The semantic side allows us to focus on actions, on deploying initiatives, and on reasoning knowledge between the information exchange between parties, and focus more on what is the action that we intend to produce than exactly on the underlying exchange of information to support it, which is already covered. And of course, we had to also to deal with that. But ultimately, by deploying this in the semantic side, with the help of a few tools that we've developed so far, and this pertains to what you see there on the right side, which is the semantic interoperability framework that I'll discuss in a while, and the DSO interface, which are the two exploitable results from the project, were basically for us to contribute to the electrification that we have in mind, because from the demand side, there's a massive, let's say, tendency to go for electrification of other vectors of energy that were not electrical based. And this allows us to bridging together different manufacturers and different implementations. To keep in mind, we're deploying this in several different countries, from Portugal, Belgium, Germany, Netherlands, Italy, Greece, and France. And the purpose overall is to support different use cases. And these use cases are energy and non-energy use cases. The energy use cases are the typical energy use cases, so energy optimization, energy modeling, clustering of energy assets, flexibility for different clusters of participants, and optimization overall. Non-energy has to do with the retrieval of information that can not only support the energy use cases, of course, but also to provide additional information that was not available to begin with. One of it could be, and you can easily understand this, the information retrieval from the state of some of the appliances to identify issues on the grid, for instance, or to use some other probing mechanisms that may exist on the demand side that can provide additional information for grid operators, for instance, on voltage profiles. So all of this is part of the non-energy use cases that are supporting overall the project. So anyhow, if we move along, just to show you and to talk a bit more of the semantic interoperability framework, this is the core of the project. So we are focusing on this domain-centric interoperability, and basically, in order not to be too detailed here on the description, but I'll prefer to have this open questions. The idea is to have this plane in which every service that we develop, ranging for platform A or platform B, are able to interact with each other, making sure that they have a proper interconnection point between them, where they are brought into the same layer, where they can register not only what is the service about, What is the underlying security and cybersecurity needs for that, and also the services that are necessary to support and to manage those services. So these are the key 3 points. The idea overall of this interconnection point is to be modeled on the semantic interoperability side. And to do that, we have what we call a service-specific adapter, which is a software artifact that is developed for each of the interconnection points to deal with, let's call the private domain of each of the implementers of each of the service providers. Why is this important? Why was this a centerpiece, and is a centerpiece from the project? It's important because it ensures the semantic interoperability between the two sides of the digital platform. So we're focusing on the services supported by the proper, of course, the proper standard, the proper ICT standards. But ultimately, who develops the service from the digital platform A doesn't need to worry about the interconnection point at all times. So you can clearly decouple the development of the service from the connection point. These SSAs that are being produced from the project, which are widely available in our GitLab platform that we host, and most of our results are, by the way, public, allow them to easily reach out and to implement their own structure here. Why don't we deep dive onto the ecosystem of each of the providers? Because at some point we are dealing more or less with private and sensitive information that pertains to business strategy and to advantage in the market. So if you see in our consortium, we do have manufacturers that are actual competitors in the market. And the only way we had to do that was to ensure this on a semantic plane. On top of that, and that's the added value on top of that, we do have this part of semantic reasoning. So we're then exchanging not just information, but rather than information, the actions that information can have, and standardizing that information. One example, just for you to keep in mind, is to make it clear. For instance, the delayed start of one appliance is perceived as the delayed start as the action, and it's implemented by all manufacturers that we have in our project in their own way. So if they want to define a relative time to implement that, if they want to implement an absolute time to implement that, that's okay. They do need to uphold the basic implementation criteria that's displayed on SAREP, and this is why SAREP is really important. Support from ETSI, it's fundamental to achieve that. The DSO interface that I've mentioned earlier, it's one specialization of this process, of this framework that easily that covers this ground that's generic for the semantic interoperability framework to the grid side. And this specification allows the integration of infrastructure such as smart metering, such as management systems for grid constraints and whatnot from the DSO side. In that matter, we do have a support of 3 DSOs in the project, and the additional 2 that are joining us on our final use case that I'd like to show in the next slide. So all of this is supported by, it's being demonstrated in different use cases as mentioned, but in the next slide you'll see a use case that it's being actually fostered by the Commission, which is based on the energy applications that we're developing. So I don't know if our colleagues will just move about to the next slide, please. Perfect. Okay, so one thing that allows us to definitely show that the project is in line with different applications is actually our support now to one of the challenges that was brought in by the European Commission to the project, which is in fact to develop a set of energy applications to allow the end users to make use of widely spread information to actually make sure that they play a role. And I heard a colleague in the previous presentation highlighting that, to make sure the technology will be provided to them in order to be able to make our European society more resilient to energy crisis like the one we're facing right now for the points and events that we all know. But ultimately, this shows that this challenge that was launched by the Commission and supported by the project was not originally foreseen in the project, but it's being supported by it because we do have the semantic interoperability framework as a result that supports this. So ultimately, in this challenge that we need to pass information to the end user, 2 things can happen. The end user can react on its own if it doesn't have technology, but it has access to technology, to information and digested actions to implement, which is very, very important. And ultimately, if he has automated systems, if he has already some intelligence deployed there compatible with semantic interoperability, then he can rely on this set of platforms to deploy actions in an automated fashion. So This is just in a nutshell one of the examples in which was not foreseen for the project. It was a challenge launched, and we are still able to do that. And this is possible because we have a service store for the service to be implemented. We have a knowledge engine to exchange information and meaning of data, and have the adapters that we have been building up on the project to achieve that. So this is a really good opportunity. We're achieving that. On a final note, I know I'm taking a bit more time. Just to tell you that this is part also of an open call schema. The project also has a part of a cascade funding, and this is the second open call that it's open on the project. So I'll invite you to check the project website. If you need additional information, feel free to get back at me, where we have a significant amount of funding for 7 companies to produce 7 demonstrators in Europe, also to support these energy applications at the European wise, where a recommender at the EU level will be provided with interactions with the grid side too. So just to keep this under discussion, to promote the discussion a while, this is my presentation right now. So thank you very much. Open to questions.
Thank you very much, David, for your presentation. But let's move on to the second project, Elia's Moonshot Asset Management Project. William, please take the floor.
Hello, everybody. Good morning. I'm very happy to be here today next to my esteemed co-panelists and the very big and prestigious projects here at InnoGrid that are presented. I will present today somewhat very practical in-house project at a TSO. Looking at the time, I'll try to keep it sweet and short. At Elia, we have a moonshot program where we have different moonshots in all our key areas of our business. That's why we have a little bit of a silly acronym, the MAM, the moonshot in our asset management department. If you can go to the next slide. This moonshot states that Elia Group would be able to resolve overhead line incidents in real time. Incidents are any occasion where the circuit breakers are opening. This can be caused by multiple things: material failure, cranes, or objects hitting the line, even animals. The goal of the project is then to have a quick or automated impact assessment of these incidents. We want to know fast and what exactly happened. This will shorten decision-making time in the field. It will remove constraints. Constraints revolve around trying to resolve an incident without knowing what you will find when searching for the cause of the incident. This project will be necessary, of course, because we will utilize the grid more and more to its limit. The goal for us has been split into 2 tracks, where we try to prove the feasibility of machine learning and remote technologies to help with this. On the first track, we are using all kinds of data, from fault recorders, asset-specific data, external data such as weather, where public works are happening from the public databases from the Belgian government, or in Belgium from the regional governments. Bird risk maps, but also eventually electrical characteristics of the faults that are in a ComTrade file format. These have to be extra processed before putting into an algorithm, of course. On the second track, we have shortlisted an amount of new technologies to have extra eyes in the field. A clear picture of what is transpiring and in real time of a clear picture of what is happening in the field will provide us with the capability of responding immediately with the best information we can possibly get. Examples that are shortlisted here are drone in a box, smart camera, and satellite. And a drone in a box, just for your information, is literally, maybe already all of you know that, but it's a drone in a docking station placed in the field. How does this contribute to digitalization? We can see that in the next slide. I have a very, very big arrow here. How does this contribute to digitalization? Well, the project builds upon one digital functionality in order to get more information in a faster way on incidents. The first step is then to having this tool available to build up experience and improve it. We eventually want to go to fully automated post-incident analysis, where this AI or this machine learning algorithm plays one part in. What we want this project eventually to do is to spark discussions about decision makings, because a tool should never make the decisions itself. We believe that only a person can make decisions and a tool can only provide decision support. And this is an example of the trajectory we see. At Elia Group, we have the vision of a digital dispatcher that gets supported by AI and other tools to make better and faster decisions. In 2022, for example, we did a first proof of concept, proving that an AI could also support in controlling the voltage of the grid with updated fault control. In 2023, we are taking that project also a step further towards implementation. For our project 10, this is what we're talking about now, the results on slide 3 are, we are pretty happy with the results. They're pretty, for the first track, which you see on the left-hand side, with great results because the algorithm could predict with 85% accuracy what was going on in the grid, what the cause was behind an incident. So it was just fed data about the incidents and then predicted it. Here you see a confusion matrix. In the rows you see the real cause, and in the columns you see a predicted cause. In the diagonal, you want all the numbers to come as close as possible towards 1. So you see here that that we come pretty close. We did this with our partner Insight, and this immediately sparked discussions about how we can change our operational rules, if we should change our operational rules immediately. And this is the spark that we are actually looking for, that we are trying to have and to stimulate the business. In track 2, on the right-hand side, you see a clear picture. You see a drone in a box opening to give this drone was remotely operated over a 5G network. And it could respond immediately towards anything happening in the field. And it gave a clear picture of what was going on. And this is for us the clear winner of remote technologies because it has very fast response times. And to conclude, the most hopeful part here, to me, it's clear that people throughout the organization are themselves asking when and how to change the operational procedures based on this already ahead in time. And this is a good sign that some previously brought about cultural changes to embrace innovation have successfully landed, and that we are ready to embrace digitalization as an enabler. To come back to the question of the InnoGrid question. Yeah. Thank you.
Thanks to you, William. We'll see you back in the discussion later. We now move to the third project, another Horizon 2020 project looking at digitalization of DSOs. Ferdinando, the floor is yours.
Thank you, Selena, and thank you, everyone. First of all, I'm glad to be here today, and thank you for this opportunity to present Platone project. Platone project is close to the end because it started 4 years ago. So we will finish our long travel in August, but we are now able to present some concrete results about the digitalization and what we propose a solution from the Platone project in terms of open solution for the DSO and the other energy stakeholders. So the main goal of the Platone project was to provide a very seamless integration of the network and market operation at the same time, thanks to an open source multi-layer framework. That is the main solution provided by the Platone project that I will show later on. So we have one main strategic challenge that is to addressing the needs of the DSO. That is at the center of the Platone vision, because from our vision, the DSO plays a key role in the digitalization process. So we need to satisfy or to address the needs of the DSO in order to have the possibility to have insight about the real-time operation on the network, trying also to unlock the flexibility market in a fair way. So we would like to produce a cost-effective and seamless solution for the DSO in order to support the integration and collaboration with the other energy stakeholder, including the customer as active player, but also the other system operator, the TSO. And the strategic objective was to realize an open framework based on blockchain technology that in our mind is one of the key disruptive technology that could be a game changer for the digitalization, in order to provide this integration of the distribution network operation and market operation, integrating the customer, the local prosumer in a very open market structure. The Platone project have a very good consortium because we have 3 DSOs coming from 3 different countries and also research institute and big and small industries that can collaborate with each other for preparing the result of the Platone project. So next, please. So as anticipated, we proposed and implemented this digital solution that is the Platone Open Framework. The Platone Open Framework is a completely open source framework based on blockchain technology. As you can see in the architecture, we have the 2 of the core platform of the Platone Open Framework based on blockchain technology. So we have blockchain both in the service layer in order to provide a very fair and transparent market for all the market participants, and in the access layer that allow us to integrate the customer network data in a secure and transparent way. Then we have a very important core component that it's focused on the DSO's operation. And I will try to give some more insight about these 3 core components in the next slide. The 3 key objectives of the Platone Open Framework was enable a secure energy data sharing, ensuring at the same time data ownership and governance, because I think the data governance and data privacy are very important aspect to be prioritized and taken into account into the digitalization process. The second key objective is the allowing a standard flexible integration of external solution and external services, because we don't want to change completely the approach and the solution that already exists in the DSO environment. But we would like to provide some additional solution that easy to be integrated and can extend the feature of the existing system. Last but not least, the creation of a fair flexibility market involving all the energy stakeholders, including the customer, with an active participation in a transparent way. Next slide, please. So in terms of results, I think the Platone Open Framework is the main result exploitable from the Platone project. As anticipated, it's completely open source, is made available as modular framework. So we tested the Platone Open Framework inside the project, in lab, in Hacken Lab, and also in the 3 real field tests in Italy, Greece, and Germany, with different configuration. So the approach that we use for the Platone Open Framework is to have this reference framework that could be used and implemented at DSO side as a complete framework, so including all the features or the components that we provided in the framework, but also as a modular framework. So some of the DSO can decide to use 1 or 2 or the core components, but not the entire framework. This is the idea that we have for the Platone Open Framework. And all the 3 components and all the entire framework integrated, it's available under a public GitLab repository that it's available for everyone. Going in detail in the 3 core components, so the market platform, that it's based on blockchain technology, as I said before, and enable an open fair flexibility market involving all the participants. So DSO, TSOs, flexibility provider, customer, and so on. All the market operations are registered and certified using blockchain technology. These allow to ensure transparency and security, also providing a level of trustworthiness among all the participants because they are secure by design using the blockchain technology. The blockchain access layer that is in the bottom of the architecture provides standard and interoperable interface for the integration of the energy data coming from the networks coming from the customer, let's say. And we use a shared customer database that allow to manage the data in a unique data source, but is, let's say, provided to all the energy stakeholders in a secure way, for sure. And we use a blockchain technology for certify the transaction of the data and the collection of the data itself. So all the data are certified inside the blockchain, and all the data transaction, so when someone accesses the data, is also certified and registered into the blockchain technology. Then we have the DSO technical platform that is focused in the DSO needs, and it's an open source extensible microservices platform that allows to manage the distribution grid in a secure, efficient, and stable way. The DSO technical platform offers DSO-specific services for the network operation, but also standard interface and the interoperable interface in order to integrate any other kind of existing solution in the DSO environment in a very seamless way. This platform, it's an evolution of the H2020 Sogno project and is now under the Linux Foundation Energy community. So it was very well recognized under the open source community, because we think that open source approach and open source methodology is fundamental for the digitalization of the energy sector. An important result that I would like to highlight here, we already started an ongoing activity in Italy that replicate the entire architecture of the Platon Open Framework in order to have a 3 years experimentation promoted by ARERA, the Italian National Regulatory Authority in Italy, and led by Areti, the DSO that is a partner of the Platone project, and the DSO in Rome, in order to have this 3 years experimentation for implementing the flexibility market in Italy. You can find the link of this project in this slide. And it's all from my side. Thank you.
Thank you very much, Ferdinando. Let's now go to our fourth and last project, Smart 5 Grid. Daniele, please take the stage.
Thanks, Elena. Thank you, everybody. Okay, let's move ahead with the first slide and let's switch a little bit the perspective. I'm starting about a question to you all. Let's think about what, in which way we use the telco infrastructure in utilities. I'm working in a group, so I'm also coming from that environment of remote control and automation. So far, we use, except for some virtual example, the telco infrastructure as a black box. So we are just connecting whatever control room to the field sites, etc. So it's no more than a telegraph invented 200 years ago. So if we move ahead with the slide, if we implement 5G, for example, we will increase the performance because, of course, there is a lower latency, ultra reliable connection, etc. But still, it's a black box that moves information from one side to the other. So let's move ahead, because we forget that the telco infrastructure, next please, is a digital infrastructure. What does it mean? That if we want to use all the potential of a digital infrastructure, we will be able to adjust the telco infrastructure according to our need. Let me give you a concrete example in next slide. We can also move together. Installing a Mac server inside the telco infrastructure, that means in proximity to the field side, we are enabled to virtualize the components, so that open for a lot of implementation and a lot of opportunity. On one hand, we are increasing the resilience of the system because we don't have any more computational power in the field side. And we are able to, for example, federate more edge nodes to increase the computational power, or acting with a backup. So it's a series of opportunities offered by the digital infrastructure. Concerning the implementation on the field side, the devices are getting more and more simple. So that means that they are more stable, and it will be translated in savings, because we will do maintenance, for example, only to the software side that is installed in a virtualized server. So a lot of good opportunities for the operators. This is more or less the perimeter of the project. We are implementing 4 use cases, but not only. In the next slide, I will present the one that it's more relevant, I think, for the audience. It has been realized by our colleagues of IPTO and E.DSO, and let me thank them for the great job they did. They realized a wide area monitoring tool inside that edge node. What does it mean? They installed 2 PMUs, phasor measurement units, in both stations, in both sides of the border, connected through 5G to the edge node in what we call a network application. Network application is a new paradigm that we developed within the project, and it allows us to simplify the construction of the software artifacts. So inside this network application, there is a virtual PDC, that is a phasor data concentrator, able to compare information of the 3 frequency and phases of the tension and the currents, like 50, 60 samples with the timestamp marker per second. So it's a time span that it's I think it's really the granularity is very high compared to the actual implementations. So beside that, there is a monitoring service that gives information about how the frequency is varying, and also comparison with the historical series. And then an advisory service that is giving the feedback to the 2 control rooms that could rely, I don't know yet if it's implemented or not, but could rely in the future also in AI and machine learning, so that the system will get more and more intelligent, and it will be able to predict a certain phenomenon. Since everything is on a virtual server, it could be easily extended in a wider territory. For example, think about connecting those network applications in different areas of Europe, for example, that relying on a high speed and high computational power, we could do a monitoring that it was not possible before, only because of we are making this paradigm shift. Beside this pilot, we realized 3 more in production and distribution level. I'm not entering in detail. I'll leave you the opportunity to go to our website and check the project. And briefly, before closing, let me talk about the platform we implemented, that it relies on 3 layers. The energy layer, that it's what we are working at every day. The intermediate layer, that is the virtualization and the telco layer, and a platform that allows us to deploy and implement the network application. So concerning network application, we develop a model and implemented that model. We created a repository. It's like Apple Store or whatever store for a mobile application, but is dedicated to this specific network application. And it's a way for developers to learn from each other. And last but not least, the validation and verification that it's supporting the developers in developing and test their application quickly without the need to have somebody from our project team that it's giving feedbacks on the test execution. So it's automatically giving the test. Let's move ahead, because our challenge now, since all the platforms are ready and we are just finalizing the last integration part, is to open our test beds for external developers. So let me use this opportunity to ask you all to extend the invitation to all your stakeholders, for example, your technological partners that wants to learn more about the technology, or if you are also interested, just look for us in our website, smart5grid.eu, and you will find more information. Thanks all for the attention. I think I was on the timing and recovering a little bit of delay from the others.
Thank you very much, Daniele, and to all speakers. I think you have put a lot on the plate for our discussion. And let's deep dive into it straight away, because unfortunately we're a bit short in time. My first question would be for William. If you can come back to the screen. You have shown a very interesting slide about the impact of AI on future grids. So my question for you is, how do you see the role of TSOs and responsibilities evolving together with digitalization? And also to paraphrase a question we got in the Q&A, can AI 100% substitute decision-making?
Yeah, it's a very good question. And in a nutshell, if you are talking about a true AI that is trying to determine how a complex system behaves, you will never have 100% accuracy, because then you have a deterministic system. But without going too detailed, it's commonly believed, or that's a prevailing opinion now, that an AI or a tool cannot bear responsibility. So for actual decision making, you cannot shift it towards an AI. That's the short answer. But it is an enabler. It is an extra piece of information that is given. And that's why I think these type of tools, well, at least what I'm working with, are enablers to help decision making.
Thank you very much, William, for your answer. Daniele, you have also discussed the impact of digital solutions in future grids, and very interestingly looked into the synergy between the energy sector and the telecommunication sectors. What are, in your opinion, remaining challenges to fully exploit this synergy, and what can we do to enable this?
Yeah, I think we might need to talk more among different let's call bubbles. For example, Smart5Grid is the only project that it's in ICT call, the only energy project in ICT calls. So we are a little bit outsider, or at least when I started, I was an outsider, and for me it was a huge learning about what's going on telco, even if I'm coming from the telecommunication area. But last 20 something years I'm working in energy field. So I think we need to talk more. And on the other hand, telcos, especially for 5G, they are developing their APIs now, because we are in the middle of the rollout, the technological rollout progress, the core network that it's the brain, let's simplify it, of all 5G infrastructure. It's still in the process of implementation. So next step for the telcos will be to start developing the first interfaces for the services. maybe they will start from gaming because it's the most popular sector that requires fast computational data and distributed computation. But they are waiting from utilities to understand what is the demand from us, because imagine massive deployment of Mac servers in each and every telecommunication tower. It's a cost. Who's paying for that? Is the telco relying only on the scratching the offer of the best tariff for messages and connectivity from the domestic customer? I don't think so. So it's a lot of question marks should have been solved by the telcos on one side, and also the authorities or founding bodies on the other. And of course, from the utility, if they are interested in invest in this technology.
Thank you very much, Daniele. And I think you're right. Increasing coordination and communication across actors in the system is definitely one of the key enablers of the transition. And let's indeed look at one of the other key actors of the energy system, the customer. David, my question would be for you. How do you think digitalization will impact and influence customer behavior, and what will be the emerging opportunities for that?
Well, it's a very big question. Indeed, the technology should not be a barrier, and that's the key point. But we cannot overlook the fact that there's also a process of education to the end user that needs to be considered, because there needs to be an understanding that there is a role that they have to play, and the end user understands that their role can have an impactful way on the system operation, or can have an impactful way in the system operation. In fact, in order to promote that, one of the questions that we have on the poll was from Matti about the SIF being USB a connection. Yes, it's a very good example. It's one of the good examples that we provide here. But use strategies such as USB connections is a facilitator, is in fact what allows the end users not have to fight technology, not have to understand the full scope, but understand very clearly their role, what they can do and what impact they can cause. What we have in interconnect projects is exactly that. So we have a facilitator like a USB connection standardization based on SAREC. So it's not something that we're departing just because we thought it was something that needed to be done. It was clear that had to be done, but we did it articulated with ETSI, which means that the end user on itself can make use of different technology, change their mind of opting from one manufacturer to another, and easily have them connected into a platform that can be a platform from different manufacturers, or a platform from a provider of an energy service, which can be an energy management system that can easily connect different pieces of the puzzle and allow them to see the functionalities and not have to worry at all with the connections. The connections are, and the low-level interactions are already established by very well-known standards, and users are already accustomed to have, or at least are starting to getting accustomed to have smart lighting, smart charging systems. So all of that is there. So we're just uniting that front with the rest of the systems, smart appliances, smart systems, heat pumps, smart chargers. So all of that needs to be clustered in. And also understanding that the end user are not just committed to their own space, their own household. They're also committed to have a role when they're joining, for instance, tertiary buildings with their electric vehicles, and knowing beforehand what decisions they may have in front of them, and to be able to do the best one for them and, of course, for the whole system.
Thank you very much, David, for your answer to this not straightforward question somehow. Unfortunately, we are running out of time. I will ask one last question. This is going to be directed to Ferdinando. We have a question in the chat regarding challenges to standardization. I would like to ask you, in the Platone project, what are you doing to ensure the uptake and replicability of the Platone open framework and overcome this challenge?
Yes, thank you, Selena. I think it's a very important question, because I think that standardization and the interoperability are key elements, both for replicability and scalability of the solution. So we leverage a lot on common standard protocol, whatever it is, and state of the art on the level of standards at European level, in order to be compliant to which are the more used standard. It's a big challenge because at least at European level, there are a lot of standards and not so aligned in the different countries and so on. We addressed this kind of topic in many projects, but I think in Platone project, we found a very good solution in order to be seamless integrated among all the stakeholders that facilitate also the collaboration among all the energy stakeholders. And this open solution, I think it's the base together with the standards definition in order to have this common view about the digitalization of the processes.
Thank you very much, Ferdinando, and thanks again to all the panelists for this session. I now leave the floor to our next moderator, Valerie Reif, Research Associate at Florence School of Regulation. Valerie, the floor is yours.
Yes, thank you, Selene. Welcome everybody to the third session of today's event. I was already introduced, so I don't need to introduce myself again. The topic of this session is cooperation, and you could say that this is probably an enabler or even a prerequisite for the other big trends that we discussed this morning already, which are electrification and digitalization. So to discuss the topic of cooperation, I have the honor to invite my four panelists on stage quickly to show their faces. We have Pedro Marques, who is the Deputy Director in the Policies and Project Department of ERERES in Portugal, and today he is representing the E-Universal project. We also have Alberto Donini, who is a researcher at Fraunhofer FIT and the RWTH Aachen University in Germany, and today he's representing the INTNET project. We also have Helena Gerard, who is an activity leader at VITO in Belgium. Today she is representing the OneNet project. And last but not least, we have Parhan Farouk, who is a business development manager at Nodes in Norway. And today he is representing the Norflex project. So welcome to everybody. Thank you again for joining us. I think the structure of the session is rather clear by now. So let me just again invite our participants to put their questions into the Q&A box, and I will then pick them up. And I think without much further ado, we can start with the presentations. And I would invite Pedro to give the first presentation about E-Universal. Pedro, please.
Good morning, everyone. Thank you for being here, still being here, for the ones who still are. We're going to try to be brief. So, Universal project is a project within the same call that some of the recent Digitalisation presented projects like FlexiGrid and Platone. We bring a different approach, otherwise it wouldn't make sense. Next one, please. Okay. Okay, so we're almost 20 partners, 3 DSOs, and we're working, cooperating with real market platforms. So Nodes, you'll be hearing some more from Nodes later on in another project. Nodes and both Nodes and Inside, and also an FSP centric. We also have, of course, the research institutes, E.DSO and EASE and solution providers and Zavala's consulting. Next, please. So what are we doing? We have this UMI concept. I talk about it afterwards. And around this is something that we'll try to put together and to put in communication. DSO, a set of DSO tools, we call this DSO toolbox, together with the analysis we've made with the flexibility markets. Next, please. About the UMA. Okay, let's see what the UMA it's all about.
With the development of solutions and services that allow the massive integration of the distributed generation, energy storage, and the active participation of consumers, the e-Universal project aims to tailor the concept of the universal market-enabling interface. The UME will look to overcome the limitations that DSOs and the market experience present in the use of flexibility services by addressing the interlinking of electricity flexibility markets with active system management. The UME has indeed materialized in the conceptual architecture design and in the implementation of a standard, agnostic, adaptable, and modular combination of different APIs to link DSOs and market parties with flexibility market platforms in coordination with other flexibility users. This approach allows distributed communication without the need for a central hub. An interoperable and distributed solution for an also distributed energy world. The UME consists of publicly available APIs, allowing any stakeholder to adopt them or to extend it concerning new services, while complying with the UME interface specification. This version is under test within the demonstration efforts in Portugal, Germany, and Poland to validate its viability in different operation and regulatory contexts. The UME is now publicly available for all addressed community to adopt and collaborate on GitHub and on the project website. Test and interact. Be e-Universal compliant and be part of the energy transition.
Okay, I think you have already the answer to there's some more slides, Valerie, a couple of slides more. But while you're putting them, I was saying that I think you've guessed the answer, our answer to the question if we go for urgency or anything more. Yes, we go for urgency. So what we've decided to include here is something that helps us to move forward today without waiting for standardization that takes a long time. And so in the future, we'll be able to develop further the UMI to complete it with the non-addressed issues like pre-qualification, registration, and the settlement, the payment part of the settlement phase.
I'm not sure if it's me, but Pedro, I think you're stuck. Are you still with us, Pedro? Maybe you can turn off your camera and try again.
Okay.
Yes, now it works. Thank you. I think you have to repeat your last sentence.
Hear me now? So I was saying, with the urgency that we experience here in Europe, we think that flexibility is one of the solutions, and we must put it in active, including markets, already existing markets. So we didn't develop anything that already exists. The UMI just puts the stakeholders talking to each other in a collaborative manner. And it's here and now, it's ready to be used by anyone who wants to, and already also ready to be further developed. With that, we also have included this DSO toolbox that is residing inside the DSO, will reside in the DSO area, which will be a complement, just like, for instance, the Platonic project has suggested. So it's something that it's complementary to the already legacy systems, but it's needed, so we need this. And finally, the issue on the consumer and by implementing this project, we will manage to include the consumer as a solution by handing out its flexibility. For further developments of further exploitable results and discussions, we'll have to try to, with discussion with, for a lot of you that are here, how will we manage the UMI after the project completion? So being it open source, other projects have developed open source, we need to manage open source at EU level. And that's all from me from now. Thank you very much.
Thank you very much, Pedro. And I think you gave a good cue already for Alberto, because you were talking about the need to talk to different stakeholders in a collaborative manner. And this is exactly, I think, what the next project is about. So please, Alberto, the floor is yours.
Yes, thank you, Valerie. Thank you for this connection and the organizer for this event. Yes, I'm going to present now the Internet project. I am Alberto Dognini. I am from Fraunhofer FIT here in Germany, and also from Aachen University. Fraunhofer is the coordinator of this project, which is a coordination and support action. If you can please go to the next slide. Yes. So it's a coordination and support action that started exactly 1 year ago, a bit more, and is continuing for 2 more years. I don't have here all the list of the participants, but basically we are 13 partners with many research centers, standardization body representatives, DSO, TSO representatives. And here I'm going to briefly sketch which are the main objectives of this CSA. So Internet is about interoperability for the energy domain. And we rely on 4 main pillars that you can see here in this slide. So the main starting point that we have is that there is so much that is ongoing now in Europe in our implementation in so many projects related to interoperability. Interoperability in all its different layers and aspects. So starting from the technical to the information to the functional. And the main goal of Internet is to put a bit of order among all the initiatives and all the efforts that are created, and trying to harmonize and connect together the different actors that are working on this topic. So one of the first goal that we have, and is the yellow part of this picture, is to create a consolidated common knowledge base for what is regarding interoperability in the different aspects. So considering the repository of initiative, the use cases, the business model on interoperability, and so on. The second point that we have is the deployment of a interoperability maturity model. So something that can be a tangible tool for the users, for the solution developers, so that they can measure how much interoperable, how much applicable is their deployed solution. Third aspect is related to the standards and the governance deployments. So we don't think that in every case, always new standards are necessary. In some new applications, yes, but not always. The main effort that is required is for the alignment of the different standards that are existing right now in our ecosystem. And then finally, one pillar is related to the testing, the interoperability. So considering all the testing facilities, so all the laboratories that we have in the different member states, how we can relate each other, how we can map each other, and then create then this ecosystem that can be useful for the community to orient itself when they want to carry out this testing. If you please can go to the next slide. Yes, and here are the project contributions associated to the different categories. So with respect to the electrification, something that we are aiming at is the work on the policy and the regulatory landscapes, in particular for the interconnection of sectors that are related to the electricity, but there are also neighbor sectors like the energy for the buildings and also the e-mobility. And one important aspect of internet it's also is a role in the energy data spaces. So which are the building blocks that are necessary for the full deployments, which are the role and the challenges. Again, it's the goal is to put a bit of order in that. Regarding the digitalization, our main outcome is related to the interoperability maturity model. So here you can see in the picture one example of how the outcome can look like in the different categories that we have. Yeah, we plan to test and verify how the solutions are deployed, are implemented, and we will provide then the outcomes according to different categories of the interoperability. So measuring the syntactics, semantic, business, and governance layer. And then finally, we have a big focus on the integration and cooperation of the communities around. So as I said, we want to standardize the way of making the knowledge available on energy interoperability for what regards the use cases, business model, all the initiatives, and also create this network of solution and communities and interoperability testing labs. If you please can go to the final slide. Yes, and our role, so we cannot work as internet alone, but we have to live with all the communities in Europe of all the other initiatives. So one of our main goals is to create a formal institution, so really as an association of internet that is going to live beyond the project lifetime. And to do so, we have to start right now also to collaborate with other frameworks that are carrying out interoperability in the energy domain, but also beyond that. So for example, one of the main efforts that we are placing right now is the collaboration with the energy data spaces projects. So the 5 projects belonging to the same code for the deployment of data spaces in energy, but also on the other side, a collaboration with the DSSC, so Data Spaces Support Center, that is a cross-domain providing indications and support for the data spaces. And together with them, we are also running the Energy Interoperability Task Force, try to identify which is the status, which are the challenges, which are the recommendations for the deployment of data spaces. Thank you very much. I think that's it from my side.
Thank you, Alberto. We will come back to a couple of points that you raised later on, but let me now move to Helena, and we're going basically back to the topic of flexibility and also DSO consumer cooperation. Please, Helena.
Hello, good morning, everybody. And thank you very much for having the pleasure to introduce you to the OneNet project. OneNet, One Network for Europe. Next slide, please. So the OneNet project, it's one of the, it's actually one of a kind, I would say. It's the only project which was selected in the DSO consumer call for large-scale demonstrations of innovative grid services. And it's really a project where it's logic that it's in the session on cooperation, because we need to cooperate with 72 partners in total. It's a large consortium with a combination of TSOs, DSOs, but also a lot of IT companies, R&D, SMEs, you name it. The project is now in its final year, and it's now really the time that it's very nice to interact with the other community to discuss our results, because we are now working on a roadmap for one unified vision for Europe, one common market for Europe, supported by one common IT architecture. But obviously, you cannot claim that you have a vision on a unified vision on markets or IT if you don't demonstrate it. And this is also what the OneNet project tries to achieve with 15 demonstrators in total. They're organized in 4 clusters, and all those different innovations in terms of markets and IT, which obviously are also based on all the predecessors and previous projects on TSO-DSO coordination. They try to bring them together and to look for, on the one hand, harmonized EU solutions, but on the other hand, also in some cases, a local solution when it's needed. Next slide, please. maybe giving you a short zoom on what we have been doing on the market part. And the goal there was really to move towards a coordinated and an integrated market. A coordinated market, what does it mean? When we look at all the different fragmented building blocks, you can say that in some cases it's operationally not efficient. So there, the goal is to look for those solutions that make the operational functioning of energy markets better, so that we can have more flexibility, but also that the flexibility can be acquired in a cheaper way, in a more efficient way. Second dimension is integration. What do we mean with integration? We want to bring as many flexibility as possible towards the market. We want to engage as many consumers as possible. In order to do that, we need to focus on aspects such as market access. And typically that's what we mean with integrated markets. How do we bring as many stakeholders within this pan-European ecosystem? Are we there yet? That's obviously the big question. And that's what is highlighted on the slides in the big table, that we see that there are today significant barriers that exist and that hinder exactly this coordination and integration. We clustered them within the OneNet project in 8 big categories, but it's clear that those barriers actually limit the ability of, for example, FSPs to develop those business models that bring flexibility to the market. A typical issue that we see is the problems of value stacking, or let's say the lack of the ability to stack value, which means that the business case is not there and the flexibility as such is not coming into the market. Other example is that typically we see that there is a big emphasis on electricity, while we also need to think about energy, other energy carriers, and even beyond. And so what are the options for sector integration, and how can we remove those barriers within the energy market that hinder today, that we don't see those business models yet popping up? The assessment of those barriers has been done within OneNet. We have developed a lot of solutions that are tested in the different demonstrators. You see that below on the slide. Every block is representing a different demonstrator, which is focusing on one of those barriers. So I invite you to read our deliverables and obviously also following the roadmap that will summarize those solutions. But I want to highlight one solution, which is maybe, I would say, a good example of how OneNet tried to go beyond what was already there. That's on the next slide. It's an example that comes from the Northern cluster. Typically, what we have been trying to do there is to solve the issue that at one moment in time, multiple system operators have different needs for flexibility. They might have different product requirements. They also need flexibility both in long term and in short term. And obviously, there's only one source of flexibility. Or to say it differently, you can use the flexibility only once. How can you organize that in an optimal way? And that's what this demonstrator is focusing upon. First of all, there is a flexibility register where there is a harmonized and integrated uniform access point for all flexibility that can be offered. Second big block is the harmonization of flexibility products, where typically, where it's possible, we look for the harmonization of product specifications so that they can be easily used not only at a national level, but also cross-border, and even that there is a decent connection with other platforms like Mari or TER. And then thirdly, and that's the highlight here, it's the E.DSO coordination module, where we actually want to develop this module that will tell or define the optimal solution when and where a specific source of flexibility should be allocated to one of the system operators. So it tells you how should we divide the flexibility among all the needs of different system operators that cooperate in the most efficient way, cost efficient, but also operationally efficient. And that also includes a detailed grid impact assessment, but it goes beyond the traditional merit order lists. And what is interesting, that this is typically compatible with existing energy and flexibility markets, which are today still often fragmented, but it tries to bring them together, and it gives exactly that intelligence which is needed to bring all those different pieces together. So it's a kind of interoperability, but not seen from the level of the data, but interoperability seen from the level of market processes and product design. I think that's typically an example of what OneNet tries to achieve. And I hope that I have convinced you to follow our roadmap, and thank you for the presentation.
Thank you so much, Helena. And we will immediately move to the fourth speaker, Farhan, who is presenting the Nodes project.
Yeah, thank you very much. I will just quickly share my screen so that you can see my presentation. So first of all, thank you everyone who has logged in, and also to E.DSO and ENTSO-E for organizing this event. Great to be here. So I'm Farhan Farouk. I'm a business development manager at Nodes. And today I will be talking about NodeFlex. So I think it's kind of a nice closure to all the things discussed before. It's a real practical life example on how to solve problems for the DSOs and together with the TSO when it comes to energy transition. So without further ado, let me present you the problem that we were facing before this project started. So we have a DSO in Norway where this project was initiated and partially supported by Enova, which is one of the funding agencies here by the Norwegian government. So Glittrenet, or previously known as Agdernet, had the challenge that they are getting more or less 1,000 to 5,000 megawatt of capacity connection requests. And they have already forecasted that their peak capacity is going to be above 5,000 megawatt, which will be representing almost 5 times increase of their peak capacity of their network, which is around 1,000 plus megawatt. In this case, they have few solutions that they looked at in order to solve this problem. One was to reconfigure the grid and also build more grid. Basically, that's something that is ongoing. Then there was an option to use bilateral agreements, or we call them non-firm contracts, based on tariff adjustments to allow some of the charging operators or some big industries on other basically loads to connect. And then the final option was also to use local flexibility markets in order to use flexibility to be able to allow these increased connection capacities and still be able to do the work of a DSO as per their mandate. So this project, NodeFlex, focused on solving this problem of basically able to connect more capacity into the grid using flexibility markets. And essentially, what does it do in terms of this session's main goal of cooperation is that when we bring the DSO or the TSO on board as a system operator in this value chain, and they bring their problem and they want to solve it using a flexibility market, then we also see their participants that are coming together with them that are usually also called network operators or ICT provider tools for smarter grids that come with the DSO in order to have more observability into the grid. And then on the other side, where the consumers are, we are seeing more and more roles of technical aggregators coming in. These are companies and startups, scale-ups that have specific expertise on making algorithms, optimization, softwares, hardwares, combining and allowing all these decarbonized assets to connect into the value chain and to be able to be more proactive than passive consumers. And that's where the another role that comes together with technical aggregation is the commercial aggregators. These are the they can, for example, be together one role, so both doing technical aggregation and commercial and participating in the market, or there can be a separate role. And we saw both of these kind of entities participating in the NodeFlex project, and that altogether is enabled by a centralized independent marketplace, which allows both the seller and the buyer of flexibility of one common point to have a common language, location, and volume of flexibility. So what NodeFlex did was that it demonstrated how you can procure flexibility and you can make available over a season, over a week, and over a short period. So the long flex basically is a product that enables a DSO or even also a TSO. In this project, we looked at the DSO to able to reserve flexibility over a long period. Then When the gate closure time of 120 minutes happen, then you are in the short flex market 7 days before the flexibility trading starts. And then once the orders are matched, the market basically clears and is able to settle all the payments and everything through the nodes platform. And eventually what it did for the DSO was able to solve the congestion problems that they were facing in the grid. So this is my last slide, basically to tell you a bit of difference on why we need to start early, because it takes time to develop such a market. So in our experience in the NodeFlex project, we saw that in early 2021, we only saw industrial loads participating in the market. Then in the later half of 2021, the commercial assets starts to participate. Some charge point operators or commercial entities started to see a value there. And then eventually, when we came to the last 1 year of the project, we saw a high volumes, over 80 megawatt hour of flexibility being offered from households. And this is usually coming from heat pumps, from EV chargers in Norway, which is very big resource right now due to a high amount of electrification here. And then eventually also other assets like battery storage and other CHPs and solar PVs also able to participate. So finally, the results that we have over 4,000 assets that have participated in this market. I told you all kinds of assets can participate, both production and consumption. We had over 1.4 gigawatt hour of flexibility that was actually traded and activated by the DSO. And then we had over 30,000 trades that were executed over this period of 3 years in this project. So now we are entering the next phase, and we are basically inviting more and more grid partners to join us, because all we need right now is more interested DSOs to participate. And together with this, in this project, we also looked into how to forward those orders that are not matched to the TSO reserve market, basically MFRR market, where we also were able to collectively make the orders forward after this market of nodes was basically closed. So that's pretty much it from my side. But if you have any questions, feel free to answer. Thank you very much.
Thank you, Farhan, for sharing the success story of nodes with us. I would now invite the other 3 panelists also to join us. And I had actually a lot of questions myself prepared for you, but I see that there are very interesting questions in the chat. So I will ask those. And the first one is to Pedro, and I think it's a very vital one. There is Matti who raises this issue of a lack of a commonly agreed interface for flexibility. And Pedro, he basically asks you if your solution that you develop in your project is the final one. So have you developed the final interface, or are we going to need others?
Yeah, there's no final, so, and we must at start agree on what's next. So what I claim is that my solution, not mine, but our project solution, is one of the solutions that can be up and running right now. So it needs further development. It needs for an involvement of interested participants and stakeholders, but it's working. It has been done together with 2 real market platforms, and so all of us have adapted. It works, as I said, with 2 market platforms, with an aggregator. It's open, so we've made it as open as possible to comply with other specifications from other market platforms, and it's easy to implement from everyone's point of view, particularly the DSO. Some of the DSOs don't have a lot of IT skills or IT support, and so we've done it without a lot of effort that usually is needed when these things are tried to be implemented. So we aim to make it have further develop and evolve to make it evolve as a standard in the future.
Thank you, Pedro. And I think, Alberto, there is a question that goes a bit into the same direction for you, because Pedro basically says that there is still an evolution to come. So they have not developed the final, let's say, interface. And then the question for you would be, is INTNET, let's say, the final community that we need, or are you also working maybe on something that will outlive your project, as I understood from your slides? So maybe you can also develop your thoughts on that one.
Yeah, I mean, I think that in the same way we are making steps forward, but we are bringing bricks. I don't know if we are going to complete the full opera. I mean, as I said, INTNET is working right now. We have a plan to have something that is lasting in the long term. What we plan to do now, so what we are carrying out now, is to test the specific components that we have that can be useful for the whole community. For example, what we were doing in the last month was to carry out this hackathon to test the CIM, so Common Information Model, and CGMS, how it can be really implemented at a large scale in different instances, in different configuration of the member states. What we try to do is bring help to harmonize the different deployments in the European level. Of course, there is still a lot to do. So our work is also to understand which are the challenges and which are the recommendations or the actions that are needed in order to solve these challenges. For example, we see that beyond the EU legislation, it's also a matter how the individual member states are going to implement this legislation. One example that I have is, for example, the accessibility of the smart metering data. So how these data are available in each country. It's something that maybe can create an issue when we have to carry out a data space that is across country. So we try, for example, to point out this and suggest some federation of solutions that can solve.
Thank you, Alberto. We also have a question that I would like to pose to Farhan, because Farhan, your project is a bit of a different animal from the others. You're not a research project. You really, let's say, came out of the market and you're answering to market needs. So there's this question by Matti who says, is the necessary investment for flexibility, can it only be market driven, or do you think that there needs to be some kind of European legislatory initiative to really drive these investments that we need?
Yeah, very good question. I think the answer is yes and no, because at the first point, what we see, at least in the demonstration project that we ran and the other areas that we're running, is that the investments in flexibility itself, like the assets and the technology, is basically being driven by the commercial sector. So we had 8 aggregator companies that were participating. They have already developed a lot of the interfaces towards the market, but also they had their own assets, their own portfolio of flexibility, and they were able to invest in that. But I believe that definitely if the EU legislation or even national, I think, regulatory agencies are able to really bring this up at a much faster speed, the regulation for flexibility and specifically market-based, then we might see a whole value chain developing quite at a rapid pace than it is today. But we definitely see, like, whenever we have a dialogue with any flexibility provider, they always look into the numbers, they do their own business case evaluation, and they see that the market prices are over 850 euros per megawatt hour, and they see that there is no brainer for them to invest in for example, a battery storage or aggregate few chargers to provide flexibility. So that's what my answer would be.
Thank you, Farhan. And there are also 2 questions for Helena, and I think they tackle 2, let's say, elements of cooperation. One is within the OneNet project. So how do you include consumers? What are the mechanisms that you use and how successful have you been? Because it also proves challenging in many projects. And the other element is, I think, related to cooperation outside the OneNet project, so between the OneNet project and the other market parties that maybe have not been included in the project. How do you facilitate cooperation with those?
Yeah, thank you for the question, Valerie. So first, looking at the consumer, so indeed, OneNet is focusing on the interaction between TSOs, DSOs, and the consumer. So what do we do to engage consumers? I think the first thing that we did or are still doing within OneNet is to try to look that our solutions are consumer-centric. So that's even independent of the feedback of the consumer, but we try to at least overcome those barriers typically for consumers. Have we invented those barriers ourselves? Not at all. So we did, for example, survey, but also workshop with consumers to also challenge the theoretical barriers that exist for consumer engagement to see whether we're actually looking a solution for a real problem. I think that's something that was considered very useful because literature is not always representing what real consumers are thinking. So we have within OneNet 4 demonstrators that actually involve real consumers, and we used survey but also workshop to really figure out what are the barriers. Then the second stage, like I said, we tried to develop those consumer-centric solutions and typically remove those barriers that are at least perceived by consumers as blocking. Some are more technical, related to tools, interoperability. Some are more market or economic. There is not enough value for flexibility today. That's why we think about solutions for value stacking, or to improve value stacking, or very technical elements like the minimum bid size to participate in a market. But it's not only technical, it's not only market, it's also often behavioral. And that's something where typically we also saw and noticed from these consumers that often they don't have enough knowledge on the topic. There is risk, or at least they perceive a certain risk in participating. And this is something where it's clear that we need to communicate more, but also we need to communicate in a different way. We already tried to do a first attempt, again, with having a workshop with consumers to explain more what is flexibility markets about, to take away the lack of knowledge and also, well, I would say some fear to participate. But it's clear that we can move beyond. And that's also with the answer on the second question, how should we engage further? How should OneNet and the solutions that OneNet has engage to the wider community? And that's something that we have developed within OneNet. It's called Griffon. And Griffon is a stakeholder, you could summarize the stakeholder consultation forum where we will do very interactive workshops with stakeholders within and outside the consortium, where we try to pitch our ideas, capture the feedback, of course, the positive feedback, but definitely also the critical questions, the barriers that are still seen. And we try to come up with novel solutions, answers that are then demonstrated in the project. And ideally, this Griffon has been, I would say, a forum that has been run across the lifetime of the project. Now we're coming to an end. Now we want to have this roadmap. And this roadmap is not just a roadmap, we call it also a living document. And this living document will really take into account the feedback that we received from outside, the solutions within the project, which was an iterative process. And ideally, this can really be, I would say, a piece of work that can be used not only as an outcome or an ordinary deliverable, but as something which is done together between the community and OneNet based on the stakeholder discussions.
Thank you, Helena. So good for our participants to stay tuned, and not only on the OneNet project, but of course also on Nodes, Internet, and eUniversal. And I think the panelists have shown very nicely that cooperation is indeed very much needed to drive the energy transition and to integrate the energy sector further. And it's not only necessary to think about cooperation in the project, but also among projects, and even to think about the lifetime after the project, which is something that I think is very nice also when you think about exploitation of these innovations that have been developed in this project. So thank you very much, Farhan. Thank you, Alberto, Helena. Thank you, Pedro. And I will hand over to Selena.
Thank you very much, Valerie, and thanks again to all of our speakers today for engaging in this very insightful discussion. We're now moving towards the end of our event, so I invite George Paunescu to take the floor again for his closing remarks of today.
Yes, thank you, Selene. And let me thank to all participants for this very rich and informative session. It's not that easy to summarize, but let me present you some of my takeaways. I have a couple of general ones. The first and very important one is that we witnessed research and innovation in action at its best, providing pragmatic solutions and answers to the current challenges of the energy sector. And looking at the themes, electrification, digitalization, and cooperation, these are not, I mean, we come, at least myself, I came to understand very well now, very clear that they are not separate matters, but they are deeply intertwined. They are just the three facets of the same main topic, which is the green and digital energy transition. So I saw it in this session like a tripod. One, we cannot focus on one of these dimensions without addressing the others. So I think the session might have coined a new energy trilemma, which I propose to call it the trilemma of the energy transition. As specific takeaways, my conclusions will cover all the three dimensions because it's not practical to disentangle them. I think we started with some challenges, and we saw the profound transformation of the electricity system and the energy system, increased shares of renewables, and in particular distributed renewables, which are changing the landscape. Electrification of the use cases, such as EV charging, heating and cooling, which bring sector integration across multiple energy carriers. And all these bring great impacts on the grids at all voltage levels. And then we have a number of needs that stem from all this. We need flexibility in the energy system. We need to continue building mature services and markets for the flexibility. We need storage solutions as part of this flexibility, storage solutions integrated in the grids or managed through virtual power plants and so on. The smart grids are a fundamental component of a modern energy system. And more generally, smart solutions are needed, and they rely on digital technologies. And that raises in itself new problems and new challenges, such as interoperability and cybersecurity, which are both critical. Data sharing is instrumental in a digital world, and with specific issues like security and privacy, which are prerequisite for data sharing. We heard also of the artificial intelligence as a very important enabler, but we heard also that should be used carefully and only under human supervision. And we need new and innovative tools for operating the grids to provide security and stability and to cope with these changes, this profound transformation. And we need new business models and participants to the energy markets, including in the markets for energy services. And for that, we also need regulatory sandboxes to make them possible to test them first. And as responses, we saw lots of good pilot projects, demonstrators are implemented, and we saw a very rich landscape of solutions that are built and tested, which is very good. On the technology side, there were discussions about hardware and software technology solutions that are developed, the use of open source software and open APIs that bring benefits, and then interoperability is a key, starting from the upper semantic levels, and when possible down to more syntactic levels based on standards, again, whenever these are available. But also importantly, on the organizational side, the grid operators are in the front line and they take action. We saw both TSOs and DSOs doing that, but there's a great need for cooperation, and we saw great examples for cooperation among the whole spectrum, the key players along the energy value chains, not only the operators, but technology providers, providers of services, obviously academia and research, and consumers. And on the consumer side, we saw demonstration of energy communities, how are being set up and empowered. This was very rich, but then what is next? What can we envisage after that? And then I heard calls to fully develop and continue mature all these solutions, to build, to use them beyond the lifetime of the projects. And for that, we need to scale them up and spread them across the EU for reaching economies of scale and turning them into established practices. And I think by doing so, we'll respond to both the main controversy facets of today, the energy transition and the urgency feature. And again, by doing so, I think we'll bring some of the needed balance into all this. Thank you.
Thank you very much, George, for summarizing the key highlights of today's event. On behalf of E.DSO and ENTSO-E, I would like to thank all the participants of today for actively participating in this session. We look forward to seeing all of you in our InnoGrid policy session that is taking place on the 14th of June here in Brussels and online, during which you will also have the chance to further engage with today's projects in their dedicated booths. Very last minute on-site registrations are still possible, so if you have not yet secured your spot, I invite you to hurry up and register for next week. And thank you again. I wish you a very nice rest of the day and summer weekend, and see you next week.